Hey everyone, thanks for coming out, and thanks to David and the rest of the organizing team for organizing this night's AdNug. Tonight I'll be talking about building a ChatGPT client with Blazor, GraphQL, and Azure OpenAI Service. First of all, a little bit about me. So I've been building software with .NET for just a little bit over 10 years now. So I guess I can say I kind of enjoy it. I'm a proud Adelaidean, but spent the last maybe 4 years recently in Melbourne, doing Melbourne things, kind of getting around the tech scene there, which has been pretty fun, meeting lots of exciting, cool people, and working with some awesome teams. I enjoy things like gaming, cycling, beers, and learning cool things, most of all. And currently I work as a consultant with Azenix, which is part of Mantel Group, and we are a .NET and Azure consultancy. And we do a lot of fun things with .NET and Azure and other Microsoft technologies. Got my socials at the bottom, and you can scan that, and that'll take me to my website, which is kind of like an index of my socials. So when ChatGPT first launched, I was kind of mesmerized by one thing, or two things. First of all, the content it was outputting was quite amazing for a chatbot. I'd never seen anything quite like it. But the thing that really captured my interest was the streaming responses. I just thought that was a really cool feature. So I set out to kind of build upon some new technologies I was learning at the time as well. So I've been trying to learn Blazor, which is a full stack, or it's a front-end framework, but you can write C# and it runs in WebAssembly. So the focus was to build a feature complete interface for the ChatGPT completions API. So essentially cloning or kind of building an interface that resembles the ChatGPT production interface and getting as many features in there that it could be potentially deployed to production with a little bit more work, but just enough to demo the core features and concepts. So by production capable, I mean I can't deploy it straight away to the public, but with a little bit more work, it could be deployed as a public web application with not much more work. So of course, the streaming responses with blinking cursor. One of the challenges was how to achieve that with Blazor WebAssembly. And of course, I didn't want to just build a kind of clone of ChatGPT. I wanted to add my own spin on it. So I built an embedded visualization for geographic information with Azure Maps service. And of course, have fun. This is a fun project that I did on the weekend, and it's sort of extended into a talk that I thought I'd enjoy sharing. And full disclaimer as well, I'm not an AI engineer. I'm a web developer. I don't have any kind of expertise with fine-tuning or like production use cases for AI. I've just built a user interface for an API that's already there. You can talk to some of my colleagues at Mantel Group who specialize at AI if you want to hear an authoritative source on that. So first of all, what's in a production-capable ChatGPT frontend? There's a screenshot. So first of all, we've got a persistent chat history. That's just a list of conversations you've had with ChatGPT. It's stored on their servers. It's persisted in their backends. And if you tick a box, it won't do that. It will go into private mode where they don't persist your conversations. They don't train the model on your data, but by default, that's on. We've got streaming responses as well. And we've got rich text and syntax highlighting. So that's another feature I'm going to build as well. And of course, we've got authentication and authorization. So we don't want to be able to read other people's conversations or log in as anyone else. That'd be bad. So we've got the OpenAI Chat Completions API. And this is a service that you can either use the public instance on OpenAI, or you can use the Azure OpenAI Services. That is a private instance. So to interact with the API, you first of all need to provide a list of messages with the text content and role associated with them. So for a new conversation, that will just include, say, the initial prompt from the user. It'll be one message. But every time you send a new or append a new message to the conversation, you send it off to the server with the new state of the conversation, and it will respond with the completed response. So the model will guess, or it will guess what the next message should look like. We've got three roles. We've got the end user, so that's you. The system, which is this invisible prompt that establishes the context between the user and the assistant or bot. And you've got the assistant, which is ChatGPT's role. And the way it's streamed from the ChatGPT API is server-sent events. Which, if you're familiar with WebSockets, it's like a push-only feature of the HTTP protocol. So WebSockets are bidirectional, and server-sent events are only unidirectional. So this is what a post request to the ChatGPT completions API looks like. There's the role, the system prompt, and use that to establish the initial context. Then you've got your user prompt, and that's the user provided input. And when you post that off to ChatGPT, you'll get a response that looks like this. So it will respond with what it thinks should be the next message in the conversation. And you'll see that you get a choices array. Currently, I think the API only responds with one choice, but I think they've structured it like that. So potentially you could pick multiple choices in the future. You'll also notice the finish reason there. That's for streaming over server-sent events. So I think when it's still streaming, the finish reason will be streaming. And at the bottom, you have the usage statistics. So we're going to do a demo now. We're going to authenticate and log in with our ChatGPT conversation. So here it is, the front end that I've built. So that says loading there just because I don't have any custom error handling yet. But if we log in, I'll log in with my company's two-factor authentication. I'm just going to do that in another window. And that should log me in. Hooray. So it says at the bottom, hello, John Merchant. So I now have a session with my front end. So the next thing I'm going to demo is a basic conversation. Going to wait a little bit for that conversation history to load, and also start up my backend because my backend isn't running. Bear with me for a second. The demo gods have not been kind to me today. Aha! It just took a while to load. So the reason there's a bit of a delay there is because I'm not loading from a database locally. That's in Azure Cosmos DB. So I'm going to show you what this front end looks like. I'll give it something reasonably nonsensical like hello world. Hello, how can I assist you today? And I'll ask a question like, can you show how to implement the repository pattern in C# with EF Core? That's a pretty standard ChatGPT query. And there it is, streaming out the response. Alrighty. So what's the overall architecture of this solution? There's a couple of moving parts that helped it all come together. First of all, on the back end, we're using .NET with ASP.NET Core. And on the front end, we're using Blazor WebAssembly. Now, the .NET backend persists all its data in Cosmos DB. It uses Azure OpenAI Services to get that model, the ChatGPT model, to send off those API requests to. And we've also got a Blazor WebAssembly front-end application, and that integrates with Azure Active Directory over OAuth 2. And we've also got Azure Maps as well, which I'll demo a bit later. And you can see as well the Blazor WebAssembly application communicates to ASP.NET over GraphQL. Now there's two transports for GraphQL that I'm using. I'm using the HTTP transport for queries and mutations. So if you're not familiar with GraphQL, you're probably familiar with HTTP. In GraphQL, mutation is like a post request. It changes state on the server, and a query is like a GET request. It's a read-only idempotent request. Let's have a look at the various different packages that I've installed. I've installed a lot more than these, but these are the major ones that I'd like to talk about. We'll go from left to right. First of all, we've got Blazor WebAssembly, the fantastic full or C# Razor front-end library or framework you can use to write applications purely in C#, no JavaScript required. In fact, I don't think I wrote any JavaScript when creating this application. We've got the StrawberryShake GraphQL client. I've got the Blazorize component library, which uses the Bootstrap CSS framework in the backend. And we've got the Azure Maps map visualization component, which is a Razor component, but we can pull it into Blazor. In the backend, we have ASP.NET Core, which is the web framework from Microsoft. Runs at the backend. It's really fast. It's really cool. Love it. Then we've got the HotChocolate GraphQL server, which is a very popular GraphQL server library for .NET. It can do everything, code first, schema first. Yeah, great framework. Then we've got the Azure OpenAI client, which is currently in beta. There's other ChatGPT or OpenAI client libraries out there on NuGet. But I reckon most people going forward, at least in the .NET space, will be using Azure OpenAI client library. Then we've got Azure Cosmos DB, which is a NoSQL database service, and it's got a client for .NET as well. It's kind of similar to MongoDB. And then in both the front end and the back end, we have access to the .NET 7.0 runtime. So all the language features and standard libraries you know in .NET on the back end can also be utilized in the front end using Blazor. And we've got the same language in both the front end and back end at the same time, C# 11.0. And I forgot to bring up the title. Next slide. So I'm going to show you the solution. And the IDE I'm using is JetBrains Rider. If you're not familiar with JetBrains Rider, it's cool. Love it.
It's not free though.
So here's my solution. Is that readable? Is that legible to everyone? Great. So we've got two applications that run. We've got blazorbrain.client, which is the Blazor WebAssembly project. Now, just bring up the CS project file so you can have a look. And I'll make the font a bit bigger as well. Just like that. So you see the runtime up here, or rather the SDK, is Blazor WebAssembly. And I think that enables a few different things. It enables Razor class or Razor compilation, and it enables embedding the mono runtime as a WebAssembly executable. And here are all the packages we've installed. We have the Azure Maps control, which is the Razor Azure Maps component. We've got Bootstrap 5 for Blazorize component library, font awesome, icons we can pull in, MarkDig, which is a markdown renderer for C#, and color code, markdown.colorcode, which is syntax highlighting and code formatting for Markdown. Then we've got the standard Blazor WebAssembly packages, which includes the host and the dev server. And we have the Microsoft Authentication Library, which we use for the OAuth 2 authentication. And finally, we've got StrawberryShake Blazor, which is the GraphQL client library. So in the back end, we have this web project, and this is an ASP.NET core application. So the SDK is Microsoft.NET SDK Web. And here we have the GraphQL server libraries. We have the Redis package for subscriptions, publish and subscribe. And we've got the authentication libraries as well. So we can validate the JWT the front end is sending us after it's logged in. All right, that covers that. So let's talk a little bit about GraphQL. How many people have used GraphQL before? That's pretty cool. So I find that GraphQL is suitable for rapid prototyping and evolving APIs more than REST is, because when you're evolving and building a REST API over time, what you start finding is you have to start drastically restructuring your API to support new and different use cases. And one of the common patterns to do that is with versioning. So what you'll commonly end up with is when you introduce breaking changes to your REST APIs, you end up having to go, okay, we've got API/v/1.0, API 1.5, API 2.0. And something that GraphQL does really well is you can kind of evolve your API schema over time by adding fields. So what we can do as well with GraphQL is we can stream responses, like the ChatGPT conversation responses, over WebSockets. And the reason it's a WebSocket and not server-side events is because we can initiate a subscription over WebSocket. It's a request and then response model. And also, another reason is that the, what is it called? StrawberryShake GraphQL client doesn't support SSE as a transport yet. So what this also gives us is unified state management for entities from queries, subscriptions, and mutations. So in GraphQL, with GraphQL clients and types, you have a field that's kind of available on every type called type name. And combining that with the ID field, the GraphQL clients use that for caching the entities in the session state or in memory. So GraphQL also has a great tooling and developer experience, but so does REST. You have Swagger and all the code gen associated with Swagger and OpenAPI. But that involves a lot of YAML, whereas GraphQL has its own strongly typed schema and query language. So what that gives us is we can actually write all our GraphQL fields and types as plain old C# classes that return plain old C# classes. And on the front end, you just define what fields you want from the server, and it will automatically generate all the Blazor components that you need to query that data based on your GraphQL query and mutation operations that you've defined, as well as subscriptions. So now we're going to have a look at what GraphQL queries and mutations look like in the DevTools Network tab. So I'm going to make sure that's on fetch XHR. And we'll have a look at what a query request looks like here. So in a GraphQL request, you have the query, which is the query definition of what fields you want from the server, and variables as well. So that search variable, this is the query to get a list of conversations from the server, and that search variable is just its default value, which is empty. But say if we wanted to extend this conversation history with a search feature, like a text box, we can pass that into the query later. Next, we're going to look at some operation definitions, and I've made a typo. I'm not going to let that slide. All right. So let's bring up our IDE, and we'll go into Client, then GraphQL. And I'm going to have a look at our query definition for get conversations. So here's our query type, and that query type maps to this query type in C#. So we have this conversations field that has a few helper attributes on it. Use paging, use filtering, and use sorting. So when you add those three attributes to any GraphQL field that returns enumerable or iQueryable even, you get this standard, these standard parameters for searching entities and paginating entities. So you can get a list of conversations, take the first 20, order it by descending, order it by created descending, so that way you're getting the most recent conversations. And you can pass in a search parameter as well. And that returns like some pagination metadata. But the fields we're worried about are the nodes, which are the actual entities being returned. And it returns a list of fragments. So fragments in GraphQL are a standardized way to reuse a subset of fields that you want to request from the server on an entity. So with our conversation fragment, we're just declaring which fields are of interest on this conversation entity throughout our front end. We can actually use the language server to inspect what other fields are available as well. So the next thing we're going to do is we're going to run our own GraphQL queries with a GraphQL client called Banana Cake Pop. Funny name, but it's a really awesome GraphQL client. So we'll start off with our query type. And now we need to define which entities we want from the server, or field we want from the server. So we want to query the conversations field, and then query its nodes, and then just get the titles. Bear with me, I need to update some authentication headers, which I will cheat and just grab directly out of the browser and hope it doesn't expire. Headers, there's our bearer token. Yoink. And we've got a list of new chats. So what we can do from there is we can also request its ID. So now you get back a list of your chat history with IDs, and we can go even further. We can even get created. So now you've got created timestamps. And we can go even further by getting a list of messages. And let's start off with message IDs. This is very old testing data. So what I'm going to have to do is I'm going to have to order by descending. Order by created descending, which will load the entire collection from the Cosmos DB and then sort it in memory. So we've got lists of messages associated with our conversation now, and now we can start pulling out information like the content. And the role. So you see here, the first prompt is the system prompt. And that contains a little bit of prompt engineering to establish our context.
Question.
Yeah.
Seems like GraphQL is already getting a subset of data provided by the endpoint.
Yep.
And then what was the use case again for the fragments?
I'll show you what the fragments do. So with operation definitions on the front end, you might have multiple operations that you want to return the same subset of fields. And you don't want to repeat yourself every time you define a new operation.
So it's like a subset of the subset.
Yeah, it's like a subset of reusable fields. It's essentially like a macro.
So when we actually use the data provided by GraphQL, are we using the fragments? Or are we using this bigger query?
So you'll be using the fragment types if the operation returns a fragment type, or you'll be using the entity types if the operation returns an entity type. And I'll just show you how that works with the client library. So if we go to pages, chat component, so this element here is actually generated from all of our GraphQL query definitions. So we have an operation here named getConversation, and that ends up generating a Blazor component named useGetConversation. And if we use IntelliSense or the language server to inspect the result, the query result goes into this context variable here, which is then used within the child content. We can kind of jump to the definition. So it ends up generating this code, I get conversations result. And we should be able, yeah. There's our fragment interface that gets generated. No worries. And next, I'll just demonstrate how we can query the conversations. Wait a sec for us to get a debugging context. There it is. So it's just like any other ASP.NET request, except the middleware eventually forwards it to these field resolvers. And the role of the resolver is to determine which data is going to be returned from the server. So I don't think we can actually enumerate over that, but we'll return it. And we should see it load. Or not. All right, back to slides. So with streaming responses and real-time communications in .NET, generally you'd use a library called SignalR. And you're probably thinking, why I didn't use SignalR? SignalR is great. There's a couple of drawbacks to SignalR. So SignalR does not guarantee message delivery. So imagine you're using ChatGPT and you're streaming the responses, and then for some reason it just misses a word when you're streaming the response, and you think, oh, is that the model? No, it's the say packet loss or a connection interrupted. So that's why we need something a little bit more reliable than SignalR to push that data to the browser. So with SignalR as well, the caching and state management is very much do-it-yourself. You're just subscribing to events being pushed from a hub, and then there's nothing to help you from there. So yeah, if you were to do this solution with SignalR, you'd need your own chat state management service, and you'd need to kind of wire that up to SignalR to aggregate that with data you're fetching over REST and data you've been pushed to by a SignalR hub. So what that StrawberryShake GraphQL client gives us is a unified way to manage your application state regardless of which transport it's coming over, whether it's being queried over HTTP or being pushed to you by WebSockets. All the entities get cached in a single in-memory store, and the world's your oyster, really. You can keep building on top of that. And one thing that's kind of interesting is they're working on SignalR support as, or SignalR as a GraphQL subscription transport. I think that will be implemented eventually. So here's our solution with kind of a REST and SignalR setup. You've got your .NET Core server, a SignalR client in the front end that will subscribe to the SignalR hubs, and you've also got a REST client as well. And generally what you'd do is you'd wrap both of them in state management services. So you'd declare like a chat state service that will first of all query up all the conversations by REST, and then subscribe itself to a SignalR hub, and then listen to data from the SignalR hub and push it to the, you'd have like a list of like chat messages and conversations that you'd constantly need to update. And then that will refresh the UI. So a lot of moving parts in that kind of SignalR and REST client setup. That's a SignalR solution. So what does it look like with GraphQL? Well, mostly the same, except you've removed two moving parts. You now just have a single unified client to support all your state management needs. And the real benefit of that is you can start delegating all your state management to the server. You can kind of minimize the amount of state management that you do in your front end, in your client. So we've already done a bit of this, but what I'm going to demonstrate now is I'm going to demonstrate the last two things here. We're going to observe state updates to the UI by subscriptions, and we're going to demonstrate what happens when we add and remove a subscription operation on a Blazor page. So I'm going to switch my DevTools over to WebSockets, and I'm going to refresh the page. And we'll see here that we've established a WebSocket connection to our ASP.NET server, and we can see our payload kind of looks similar to a GraphQL query that we were looking at before in the HTTP tab or the XHR tab. But this one, instead of query, it says subscription. And so that directs to the subscription type we have in our backend here. We have a few attributes in middleware that help us set up subscriptions in HotChocolate. But what we're seeing here is the page subscribing to the on-conversation updated topic with that specific conversation ID that we've provided in the route. So you see in our route here, we have route arguments, route parameters, and we pass in the conversation ID just through the route. And I'll show you what that looks like in Blazor. Pages, chat. So up here, we have strongly typed routing, where we declare that the conversation ID is going to be a GUID. And with subscription, what we need to worry about is this element here, or component that's been generated. It's a use on conversation updated component, and you just pass in the conversation ID parameter, which comes from the route. That gets injected in by the Blazor router. And that's all you need to do to subscribe to events from the server. So if I were to simply just delete that, save it, and then rebuild the client, and then refresh the page, we've just disabled subscriptions for this page. So the responses will no longer stream, but you'll still eventually get the entire entity once the mutation has completed. Just say hello. And I'm putting a lot of trust into OpenAI at the moment for these demos. So we've just said say hello, and it responded as an entire entity. It didn't respond as a streaming entity.
Try something like that.
Yep.
See how long it takes.
Yeah, we're not going to go too long. I just want to give me some short lorem ipsum, and we're going to see how long that takes. 1, 2, 3, 4, 5, 6. Also switch that over to so it did eventually respond with the entity from the mutation. Oops. Now I've done it. Oh no. Ah, phew, it's just a new tab. I'll just go to the response. And you'll see here we got back from the mutation, the add message mutation, we got back an entity with type name, add message payload. Yeah, we got back this entity with type name conversation and ID ends with 358. That's the same ID as we have loaded from the query. And so when the GraphQL client sees, it actually matches on those two fields, type name and ID, and it will update its local cache. And what will even happen then is it updates it globally. So any component that renders or subscribes to or defines that it wants data from GraphQL, it will automatically re-render throughout your entire application. So we'll just restore that subscription component now and rebuild. So a good example of that would be creating a new chat and then saying something like, give me a cake recipe. And we should see in the left-hand side, in the conversation history, it will give us a new title, offering a recipe for vanilla cake. So there's no kind of manual state updates I have to do. It just automatically rendered that on pushed data. So I'll go over how that all works now. There's a few different components of it at various levels throughout the stack. Subscriptions, IAsyncEnumerable, and publish and subscribe of topics. So how many people here have used IAsyncEnumerable before in .NET? It's a relatively new feature. But it essentially lets you iterate over streams of or sequences of entities asynchronously. And what we can actually do is utilize that kind of asynchronous nature to push out state updates over subscriptions. So we have a GraphQL mutation operation add message, so that appends a message to the conversation. We iterate over a streaming completion response within a method that returns AsyncEnumerable. So every time we get a completion streamed from the ChatGPT client server thing, we get back the new state of the conversation. So in each state update, we yield return the new state, and then that gets pushed out to the topics. So this is what a topic ID looks like. Got the user ID of the logged in user, the conversation that's been updated, and then conversation updated, and the payload for that topic will be the new state of the conversation. So when we open up that page, we actually tell the GraphQL server we want to subscribe to this topic. And I've just played this slide again. There's no way to skip the animation. Enjoy. All right, so what we're going to do now is we're going to step through the AsyncEnumerable code in C# with the JetBrains IDE debugger. And then we're going to step through the mutation. And then we're going to step through the subscription operation that yields the entities from the topic. So I think the best way to start with that is putting a breakpoint on our add message mutation. So we're going to go to API types, mutation, and we have one here called add message. We have that little tick there, so that means we're attached. I'm just going to say thanks. Thank you, ChatGPT, for that cake recipe. And you'll see here on line 66, we have this async enumeration. We enumerate over it. So we're going to wait for our first pushed response from OpenAI. And here we have the first state update that we're going to push out to a subscription topic. So it contains an array of messages. And we're going to have a look at the last message that's being appended. Thanks. So we're just pushing up to all our subscribers that we have a new message in the conversation that says thanks. So that's being pushed out. Yep.
Question, what's the difference between waiting for each or waiting for the API call responder? So using await before for each loop and await in the API when you make the API call.
Yep, so await for each tells the C# compiler to enumerate over an async enumerable. If usually you just use for each to iterate over a IEnumerable, which is not asynchronous. So we should be receiving our first pushed SSE event. And here's our bot responding with something. That's empty string for now. But if we go to the next event that's been received, oh, I need to do it faster because that I need to step through it quicker because we lost our HTTP connection to the API. It broke the socket. So I'm going to say thanks again, and then do that much quicker, and also refresh the page. Thanks. So I'm going to hit play a couple of times. 1, 2, 3, 4, and we should see a partial response being streamed out. So that's probably going to say, "You're welcome." I hope it does. That would be very polite. "You're welcome, let." So you'll see each time we step over and send the new state of the conversation to the topic, we get the new state of the conversation. Another really cool thing we can demonstrate as well with this state management is because we've delegated all our state management to the server, it's not really going to care about your context or your window context. It only cares about your session. I just need to log in again. There we go. And I'm going to load the same conversation. And I'm going to disable this breakpoint. And we will see that both of these browser tabs are subscribed to the same topic. So all the state management delegated to the server, and an advantage of that is you can start to share context between different tabs without having to do any kind of inter-browser messaging. So the next thing we'll demonstrate is what that looks like on the subscription operation side. So a good example would be subscribe to conversation updated. And that will get invoked when we refresh the page. And what this does is it sets up a source stream that we can subscribe to, given that topic ID. And so anytime where we publish to this topic, using that sender interface that HotChocolate gives us, topic event sender, with that ID, we can subscribe to it from this operation here. And that's all you need to do. You really just wrap this this topic in a source stream and then return it to the client. What else can we do? I think that just about covers subscriptions. Did anyone have any questions? Because I might not have covered everything there. Let's have a look at how I did rich text formatting. So ChatGPT by default is trained to render code and rich text responses in Markdown. So even in the production ChatGPT server, that's all rendered as Markdown. If you copy it to your clipboard and paste it in plain text, it's Markdown. So in Blazor, we can use a C#.NET library called MarkDig on the front end to render rich text from ChatGPT as HTML. And for syntax highlighting as well, we need a safe and unsafe rendering pipeline. So if you've ever used an IDE like Visual Studio Code and just been writing code and the syntax highlighting suddenly stops working, that's because the syntax highlighting engine has crashed. So we kind of see similar behavior in the Markdown syntax highlighting library when we're streaming responses. Sometimes ChatGPT will just give code syntax in a format that this library just doesn't handle at all. So now I'm going to demonstrate the ChatGPT response containing a code block, and I'll show the code for rendering Markdown content as HTML in Blazor. And that will almost bring us to time, I reckon. So new chat. Don't have any breakpoints, good. So this here is a Markdown code block, and here we just have standard rich text as Markdown. We have a reusable message component, and we take the content that we've gotten from GraphQL, and we just have this try catch here. And if we can successfully render it with the default Markdown pipeline, then we render it. If there's an exception, we just catch it, and we render it with the safe Markdown pipeline, which doesn't include the syntax highlighting. So I'll quickly demo the Azure Maps visualization. So I've used prompt engineering on the system prompt to establish a context that essentially tells ChatGPT, hey, if the user requests geographic information, it's rendered in the front end as a GeoJSON block, and then we extract that and then render that to an Azure Maps component, because the Azure Maps component can kind of interpret and render geometry features from like a JSON text payload. So we actually use a regular expression in C# on the front end to extract the GeoJSON object from Markdown block. So if the regular expression sees that there's a MIME type header, so in Markdown, you can kind of tell the renderer that's rendering the Markdown, hey, this code block's going to be application/JSON. We can actually say, okay, this code block's going to be application/geo plus JSON. Please render this as an Azure Maps component. So I'll show the code for, I'll first of all demo it, then I'll show the code with GeoJSON and how all that works. So this is one of the riskiest demos I'm going to do. It is probably going to work. Fingers crossed. I'm putting a lot of trust in OpenAI. Please render something. So I'm going to say, where are some cool places to visit in Adelaide? And because we have that system prompt, it knows to render as a feature collection. Which we can then interpret in the front end and extract using a regular expression, and then pass the extracted GeoJSON payload into the Azure Maps component. Now, I'm not going to guarantee that this is going to be 100% accurate. AI experts would recommend you to very much fine-tune your models to present geographic information or extract geographic information from your large language model queries, because I don't think by default it is trained to do that. So I think what we're going to see here are some wild guesses as to where the language model thinks these locations are. Let's go. Glenelg Beach. Did it get that right? A popular beachside suburb with plenty of cafes, restaurants, and shops. Is this Glenelg? It's not quite the beach, but I'll let it pass. Is this Hague's chocolate factory? I don't think so. So that's an example of a hallucination. What's this going to be? But, so if we were to fine tune, which you can do through Azure OpenAI Services, this with your own geographic information, you'd get pretty accurate results. But these are just from your stock standard ChatGPT Turbo 3.5 model, so you're going to get pretty inaccurate results. Or what's this one? What do you reckon this one's going to be? Is it the central market? It's getting better. It's getting better over time, hooray. And that might be the Botanic Gardens. Let's find out. Very impressive. I thought that was going to go horribly wrong. It only went slightly wrong. And of course, we can inspect the payload that we have extracted through regular expressions. Who would like to see the regular expression that does that? It's not pretty. It's not pretty. So we have this geometry helper class. And first of all, we have the regular expression that I spent a couple of hours writing. And we actually use this C# 11 and .NET 7 feature called generated regexes. And essentially what's happening here is it's taking that regular expression and then generating C# code. So it doesn't actually create a regular expression engine at runtime. It just runs C# code that matches on a string that's equivalent to this regular expression. So here we pass in the message content, and we match on it, and if it's of that MIME type, then we replace that markdown block with a little message that says generating a map for you. So here it says generating a map for you until the response is fully streamed. And I'll just show you how we wrap a Razor component, which can be rendered in MVC as well. The Azure Maps component doesn't provide a Blazor wrapper by default, but we just wrap the existing Razor component in a Blazor component. I'll just show you how that works. So for this Azure Map component, that's a Shush.
found this on the web for how that works.
They're taken over. These AIs are taken over. So that's the Razor component. And then we just pass our payload in. Where do we do that? When the internal JavaScript component is loaded, that's when we pass in our geometry information. So GeoJSON, it's a open standard. Most geographical information systems support it. And yeah, it's pretty fun to generate that data from large language models and embed it into things. Hours of entertainment. So what's next? Probably realized big things missing, tests. No unit tests. And that is because there's a couple of things in this project that the testing story isn't quite finished for. So I couldn't figure out how to test the GraphQL client properly. I noticed there is a in-memory kind of store, but I couldn't figure out how to test the StrawberryShake client in unit tests without a lot of boilerplate code. So in large language model land as well, there's something that Microsoft has been working on called Microsoft Semantic Kernel. And this stuff seems really cool, and a lot of it goes over my head. But Semantic Kernel provides cutting-edge design patterns for integrating large language models with applications. So example of that would be prompt templating, vectorized memory, function chaining, and intelligent planning. So I think prompt templating is just like providing standardized patterns to engineer your prompts and using string in place. Or instead of using string in place, you get like nice standard patterns to do that. Vectorized memory is, I think it's when your large language model application can remember and associate things your own context long term. Function chaining is when you take the output of one function and pass that into another function or capability of your semantic kernel application. And I'm still learning what intelligent planning is. So lots of exciting things happening in that space, much to learn. So another really cool thing coming soon is in .NET 8.0, we have Blazor United coming up. So in that .NET 7.0 Blazor WebAssembly application I showed you, that's all rendered in the browser. But in Blazor United, what you can do is you can set it to intelligently render components either on the front end or the back end. So you can switch between server-side rendering and client rendering throughout your Blazor application without having two different projects to maintain. It's all united into. It's similar to Next.js. So what are your ideas? Love to hear it. Yeah, if you have anything cool to suggest, let me know. Now it's question time, but I'm sure you're keen to get the pizza.
I have got one.
Yeah.
Are you passing any context information about the user to the chatbot to start with? So things like location, locale, and is there a facility to do that at the moment, or does the user have to specify it every time?
So I could do that with prompt engineering. So at the moment, we have our default system prompt that establishes the context, and that's static. It's just a standard template. But what we could do is we could substitute in like context-specific information. Like I could request access to the browser's location API, and then in that initial system prompt, tell the large language model or ChatGPT that this user is at these geographic coordinates. And I can show you what that initial prompt looks like. So you are a helpful assistant named BlazorBrain. Your responses should be rendered as Markdown. When the user requests geographical information, it is presented to the user on an Azure Maps component. You should respond with a code block of valid application/GeoJSON format. I had to do a lot of tuning to get it to actually return results reliably. So a lot of different, like playing around with different prompts to finally get it to reliably return this format that can be rendered to the component. And do not mention this code block to the user as it is passed transparently to the Azure Maps component. So what I was finding this chatbot was doing is it was saying, sure, I will render this for you, I'll render this map for you, which you can copy paste into a Azure Maps raising component. So it just started telling the user all about how the application was written. So a lot of fine tuning required. But theoretically, what we could do is instead of making this a constant string, you could substitute in information from the user's context. I forgot how to vim. Okay. We've got the user's name is John, space. So that could be substituted in at runtime, and you could tell the large language model that this is our user's name. So if I were to restart that, oh, yep. And then I'll start a new conversation. Eventually, here we go. What is my name? Yes! Really uncertain for a second there. So, any other questions?
Is your code open source? Like, can we have a look and contribute if you want?
Yes, you can go on my GitHub. I just uploaded the code this afternoon. I don't have the link on the slides, but I'll post it to Twitter and Mastodon and all the other social media links I can.
And I guess regarding the ideas, I think you can add a dark mode towards your frontend. That will give you a more like a chance to be honest.
A dartboard?
Yeah, a dark mode.
Dark mode.
Ah, dark mode, yes. Got it. Yeah, like a switch button that changes the theme. I'm pretty sure.
Yeah, we're happy with how smart this is, but it doesn't look cool.
Yeah.
Yeah, it just looks like a Bootstrap tutorial.
All right.
All right.
Well, with that, we might just say thanks to John for that presentation. Really great stuff. So.